Okay, so to recap, the idea of polynomial division pretty much bases on division of ordinary numbers, and we can look at the process behind dividing these numbers first to then work out how we do it with polynomials. Now, normally we would try and do something like this using short division. So let's work through the problem using short division and see what happens. Now, obviously 6 cannot divide into 3, so what we tend to do is 6's into 31. 6's into 31 go 5 times, and you would normally write the 5 here above the 31. Now you would stop, because obviously you would then try and work out what the remainder is, but you can't work out the remainder without doing 5 times 6. Well, 5 times 6 is 30, so our remainder is 1, which you would normally write there. We start the process again. We now look at the number 17. 6 into 17 goes 2 times, write the 2 above, and then effectively we stop, because we say, well, 6 2's are actually 12, I need 17, so my remainder is 5. 6's into 54 go 9 times, write the 9 above. 9 6's are 54, so there's no remainder, and 6's don't go into 2. Now, when we were at primary school, we would write 0, we'd write a little r, and we'd write a 2. Now, interesting, at secondary school, we tend to go, we don't do remainders, we'll put a decimal point on, and we'll go ad nauseum further and further across the page. But actually, in this instance, we're probably not going to do that. We need to do this using long division. Now, before you will start groaning, because it's like, oh, I didn't like long division, don't know how to do it, just think of the process. That's all I'm going to ask you to do. Same thing happens. 6 into 31 doesn't go. Same thing, 6's into 31 actually go 5 times. Now, 5 times 6 is 30, and what we're going to do is actually we're going to write the 30 down here, and we're going to take them away. Because 31 minus 30 is 1. Oh, hold on a moment. That's the same one we got here. Absolutely, it's the same one here. What we're going to do is we've just written it in a different place. We're formalising our working out. Well, what did we do with that 1? Well, we put it by the 7. So the same thing here, and normally we talk about dropping down. The 7 drops down, and we start the process again. But we actually say 6's into 17. Same idea, 6's into 17 go twice. Stop. I've written a number 2 on the top. 2 times 6 is 12. We write it underneath. We take away, and then we subtract. Oh look, there's my 5, just written in a slightly different place. Same thing, what do I do now? We drop the 4 down, and we do 6's into 54. We've already decided that goes 9 times. Well, written something on the top. 9 times 6 is 54. We take them away, and what do we get? Yep, we get 0. Well, still got to drop that 2 down. 6's into 2 don't go, so we write 0. Whoop, written something on the top. 0 times 6 is 0. Take them away, what do? I get 2. Some interesting facts, or rather things that you need to know. Yeah, this thing here, the number on the top, is called the quotient. Right, this thing here is called the quotient. And this, surprisingly, is called the remainder. You're sort of going to need to remember that, because I can write this in a different way, or I can write my answer in a different way. Seems a bit weird at the moment, but what I need you to think of is that we have now decided that the number 31,742 is the same as 6 multiplied by 5,290 with a smidgy little bit over. Right, so again, 31,742. So 31,742 is the same as 6 times 5,290 plus that squidgy bit at the end. This thing here is actually going to become incredibly important shortly when we look at the idea of trying to do this with algebra. Algebra! We're going to do this with algebra. Yep, and it works in exactly the same thing. So just remember, short division, one way. Long division is exactly the same process, but it just works down the page. Now, please, every time I wrote something on the top of the board, or every time I wrote something on top of my fraction, what did I do? I went, oh, I've written something on the top, so now I'm going to do the top times the bit in front, and I'm going to write the answer underneath. That's critically important. Let's go on to our actual question. Now, firstly, obviously with maths, it's important to understand what the question means before we even know where to start. And as I've said many times before, it's sort of important that we... And so here we have our question, a number of questions. Now, before we even go any further, we've got to sort of work out what the question is asking us to do. And we might need some prerequisite knowledge. So, divide P of X equals, now, what on earth does this thing here mean? Does that little thing there mean? Well, in computer speak, it's a caret, and it means raised to the power. So that's exactly the same as x cubed. That's the same as x squared, and so we can just realise that that little caret sign, as it's called, is just the same as saying x squared. So we've got a polynomial here, and it's being asked to divide by x minus 1 and write it in this form. P of x equals x minus 1. I've got a q of x and a plus r. Now obviously very helpfully it's told me here r is the remainder. Well, okay, so how does that actually help me? Well, if we go back to our previous question, then what we can see is that, oh yeah, hold on, we've got this remainder thing here. So, well, what's this thing? That could be our q of x. So now we can go back to our original question and perhaps put it in a little bit more context. So, well, let's write it out longhand first and see what the prerequisite knowledge might well be. So, we're going to divide x cubed plus x squared minus 2x plus 3 by x minus 1. Now, seriously, at this moment, you're probably looking at going, no idea what I'm going on. Well, it's actually quite easy, because initially what we're going to do is we're going to divide each term by just the x. Why? Who cares? Just do it. For this moment in time, let's just run with it. We're going to divide an x term by an x. Well, prerequisite, let's just check that we actually know how to do that first. So initially we're going to do x cubed divided by x. Well, if we go back to our basic powers story, then we find out that x cubed divided by x, you take away the power, and what does that equal? It's going to equal x squared. Okay. And what about when we have x squared divided by x? Same thing. X squared divided by x is what? X is x to the power of 1. Take the powers away, and what do we get? We get x. Easy. We know how to do this. So let's go back to where we were. So, first thing we do is we're going to divide everything by this thing here. So, x cubed divided by x. Well, that's x squared. We are not going to write x squared on the top here. The reason being is, well, like numbers, we have columns. This is my x cubed column, this is my x squared column, this is my x column, and this is my constant column. And so, we're going to do x cubed divided by x gives me x squared. Don't forget, we've already decided that here. So that is my answer, and it's simply going up onto the x squared. What do we do now? Well, I said every time you write something on the top, you stop, you go back, and now you're going to multiply everything at the front by what I've just written on the top. So, x squared multiplied by x is x cubed. Well, that's pretty good. We were expecting that because that was this conversation over here. But now we're going to do the x squared times minus 1. You're going to say, why? I'm going to say, who cares? Just do it. So you've got minus x squared. I've multiplied the top by all of the front. What did I do in long division? Oh yeah, I drew a line and I took them away. So let's just check. X cubed minus x cubed is 0. I'm not going to write 0. It makes things look a bit messy. Plus x squared. minus minus x squared is going to be 2x squared. Yay! I've completed the first part of my polynomial division. Life is awesome! What do I do now? Well, I've written something new here, so I start again. I'm going to divide x into 2x squared. Well, 2x squared divided by x to the floaty 1 is equal to just 2x. So I'm going to put plus 2x on here and stop. I've written something on the top. The minute I write something on the top, I multiply what I've written on the top by what's in front. So plus 2x times x. Oh, forgotten a step. Didn't bring this down. Remember, you had to bring that down. So plus 2x times x is 2x squared. Plus 2x times minus 1 is minus 2x. Everything on the top has now been multiplied by everything on the bottom. I draw my line, I do a takeaway sign, and I start again. So 2x squared minus 2x squared is 0. Not going to write that down. Minus 2x minus minus 2x actually gives me 0, and in this time I am going to write that down. I've written an answer, and stupidly, like I didn't do before, I've now got to remember to move my plus 3 down, and we start again. X's into 0 don't go, so I write plus 0 at the top. I've written something on the top. I now do the top multiplied by the front, and well, that's actually going to be 0. We know that that's going to be 0, and I can just take them away, which gives me 3 here. So what does that actually now mean that I've got? Well, we have our thing on the top, which we've already decided is called the quotient. We've got this thing here, which I'm actually going to tell you is called the divisor. I can now remember that we've decided that p of x can be written by this thing here is just this times this plus this bit here. So p of x becomes equal to x minus 1, x squared plus 2x, I'm not going to put the 0 because I don't need to, plus 3. Hold on, that looks strangely familiar because the question asked for it to be in a certain form. It wanted it in the form p of x equals x minus 1 q of x plus r. And hopefully, if you realised, we can now look at that and go, ah, it's in exactly the same form. So this here is my answer. With a big smiley face because I feel really good. Let's write this in a little bit more formal so that we can actually understand it. So we know that we have x plus 1 outside the brackets, and I'm going to have 3x cubed minus x squared plus x plus 2. Alright, so first things first, what do? If we remember, we're going to do 3x cubed divided by x. So 3x cubed divided by x is going to give us 3x squared. Yay! Written something on the top. Remember, the minute you write something on the top, you go top multiplied by all of the thing in front. So 3x squared multiplied by x gives me 3x cubed. And if you remember, we always want that term to be there. And then 3x squared times plus 1 is plus 3x squared. I've written something there, draw a line, take them away. So 3x cubed minus 3x cubed is 0, and for completeness I'm not going to write that in there. Minus x squared minus positive 3x cubed is actually going to be minus 4x squared. I've done a sum, I must copy down the top line. And we start again. We do x into minus 4x squared, or x into minus 4x squared is minus 4x. I've written something on the top. Remember, whenever I write something on the top, I must go back and multiply what's in the front. Minus 4x times x is minus 4x squared. Ooh, exactly what we were expecting. Minus 4x plus 1 is the same as minus 4x. Draw my line, take them away. Minus 4x squared minus 4x squared is 0, not going to write it. And positive x minus 4x is actually plus x plus 4x, which is 5x. Written an answer down here, what do? Drag the next thing down. There's my plus 2. And yay, we start again. This time we do x's into 5x. So that's plus 5 as my answer. And 5 times x is 5x. 5 times plus 1 is plus 5. And what do? I think you know this by now. You take them away. 5x minus 5x disappears. 2 minus positive 5 is minus 3. There is my answer. Now, two things. Firstly, let's actually finish this question off and let's talk about something on the next slide about the idea about remainders, because I think it's going to come in useful later on. But, as I say, let's finish the question. So we now have to write it in the form x plus 1, qx plus r. Now remember, the x plus 1 is exactly here. That's why they've chosen x plus 1. So my answer becomes p of x equals, bracket, x plus 1. What's my q of x? Yep, remember, it's the thing on the top, because we're effectively saying that the thing in front of the bracket multiplied by the thing on the top gives me the thing under the bracket, and minus 3. And so, smiley face, there is my answer. Previously, we were talking about the idea of remainders, and that's pretty tough. We started off on quite a difficult situation. Now in VCE, when this is taught in maths methods, generally what they actually do is they do the idea first where there is no remainder. Now the idea where there's no remainder is actually quite important. We're going to go back to year 7 maths quite quickly, and we're going to talk about the idea of factors. There's a number, 36. If I was to ask you to write down the factors of 36, I'm pretty sure you'll all start off with 6. Now, yep, 6 is definitely a factor, but it's not possibly the most sensible one to start with. Because in maths we tend to like order, we tend to like beauty, we tend to like things being in a nice pattern. Now, there is a number that goes into everything, and the first number is obviously 1. What's the next number that goes in? Yep, hopefully you'll agree 2, 3, 4, 6, 9. Yep, when will be the next one? 12, 18, and don't forget the number 36 itself. How on earth did I manage to get those factors so quickly? Well, I don't have them in front of me, put it that way. What we tend to notice is factors tend to happen in pairs. And there is actually a whole topic called factor pairs. And if you look at the first and the last and multiply together, what do they make? Yep, 36. Look at the second and the second from last, and what do they multiply together? 36. What about 3 and 12? 36. And 4 and 9? 36. Now, 6 is on its own because 6 sixes are 36s, and hopefully we are all happy to know that 36 is also a square number. Now, as I wanted to say, what on earth does this have to do with the price of fish? Well, surprisingly little, strangely, because the fish prices of the world don't relate anything to factors. Well, maybe they do, but I'm not getting into that. What does this have to do with anything? Well, what we know about a factor is that when I do 36 divided by any of these numbers, for example 4, I actually get a whole number answer. It's 9. I don't get 9 remainder 4. Right? So there is no remainder. The remainder is 0. And that is really important to us because we like sometimes then to be no remainder. I'm going to say that one more time. You need to know that a factor of a term or a number is when there is no remainder. So if we go back to our previous questions whereby we go, oh, what happened? We will find out, if you reverse through the video, you find out that all of the questions we did so far had a remainder. It'll come as no surprise that in a later video, some of the questions we do will seem a lot easier because there is no remainder, or we have found a factor. Well, that's the end of this lesson. Hope it was an interesting recap of what we did in the lesson today. Have a good evening.